gives me very great pleasure to introduce tonight's speaker. Professor Shusheng Pang is a professor of chemical and process engineering in our Chemical and Process Engineering Department, and he is the director of the Wood Technology Research Centre. Professor Pang came to New Zealand from China in 1991 as a visiting scholar in the Department of Chemical and Process Engineering at this university. Then from 1992 to 94, he studied for his PhD in the same department on high temperature drying of softwood timber under the supervision of Professor Roger Key. After completing his PhD, Professor Pang worked at New Zealand Forest Research Institute, which is now called SCION, as a scientist undertaking research on wood product development and wood processing. In 2002, Professor Pang came back to Canterbury University as an associate professor, and he became a professor in 2009. He has strong interest in the development of new wood-based products and their processing. He also has strong interests in using woody biomass as a renewable feedstock for energy and liquid fuels. In the past 10 years, Professor Pang has authored or co-authored over 120 papers, including 60 journal papers and 60 international conference papers. He's attracted over $8 million in funding, both from New Zealand government research funding agencies and from industry. In 2011, Professor Pang was elected to the Fellow of Institution of Professional Engineers New Zealand, or IPENZ, and also he was made a Fellow of the International Academy of Wood Science. In today's lecture, Professor Pang will introduce a new product made of wood and recycled plastics which can be used as a building material. In New Zealand, nearly 300,000 tonnes of plastics are consumed, and only a quarter of them are recycled compared to approximately 50% recycling in European countries. The objective of Professor Pang's work is to increase the recycling of consumed plastics and to substitute chemically treated wood for building applications. The lecture that you're about to hear will cover the product development, its processing technology and property, comparison with existing wood, virgin plastic materials. The lecture will last about an hour, and we will have time for questions and answers afterwards. Ladies and gentlemen, Professor Shusheng Pang.
Thank you very much, Jan, for the very nice introduction. And thanks everybody for coming. And I'm very pleased to see Professor Key is here and Mrs. Key is here. And that reminds me, and when I came here, it seems not too long ago, but I calculate the years, it's 20 years now. So I have been doing a research related to wood and also wood-based product for quite a number of years. And today I'm going to cover one of my projects on the wood recycled plastic composite as a building material. Wood has been used for widely for structure, for decoration, for furniture, so it's a quite widely used material. So why the wood is used so widely? We know a lot of advantages. It's available in many species, sizes, shapes, and has the properties to suit almost every demand. And wood is easily shaped with tools and fastened with adhesive, nails, and screws, and bolts, etc. And dry wood also has good insulation properties against heat, sound, and electricity. And the growing and ring pattern and colors make it very pleasant to make furniture or decoration. And also, the wood can be combined with other materials for both functional and decoration uses. And very importantly, wood is a renewable material. The trees absorb CO2 from atmosphere while the trees are growing. That is a very good thing. However, there are some other not very good things for the wood. We have heard the leaky house. Everybody got it. And we know when you got the day is wet, and you sometimes you got your window and the door jammed and distortion, and also the outdoor wood structure get decay. So that is a problem. And leaky house and leaky buildings syndrome affect up to 90,000 houses in New Zealand. If unfortunately you are one of them, so you are not alone. It's, in New Zealand, it's about 90,000 houses built in the last 10 years. So why this happens? Why the house got the leaky problem, got the other problem? There are some natural properties of wood. We know wood swells when it's wet. When you got the wet environment, or you put the wood in the water, it swells. When the wood is dry, and then it shrinks. So if the shrinking and the swelling is not uniform, and you got a distortion. You can see the wood here. You got a distortion. So initially it's very flat. After drying, you got a distort. And then if you got a door like this way, you possibly got a lot of frustration about this. You cannot open in a wet day, and that is not very good. And dry wood can absorb up to 30% of moisture. Are you surprised? If you put the water in a very humid environment, every kilogram of dry wood can absorb up to 300 grams of water. And at the same time, it swells. And swells to 3 to 7% depending on the moisture content change and direction. So that causes a lot of problem. And also the wood can be attacked by insect, by a fungi, or by a bacteria. And the wood lost integrity when exposed to warm water or humid conditions. So, or on UV or on the freezing and thaw cycling. So that is the reasons, the basic causes for the problem with the wood. Oh. Okay, solutions. So what's the solution? In the proper design, we need a good design. We need a good construction to prevent the water penetration into the building. We need to modify the wood. You normally use chemicals to make the wood more stable and more durable. So if softwood is used for decking, for a playground, for marine structure, you have to treat the wood. You have to use chemicals. And a very common chemical is chromated copper arsenate. Have you heard the story about the, yeah. So it's still okay in New Zealand and Australia. But in US and European countries, this has been put under a restriction. If you sell the chemically treated wood to US, you will be in a difficult situation here. So that is and that is one wood, good thing, bad thing. And we look at another separate environmental issues, waste plastics. And maybe you are not so aware of how much plastic the world is using. In 2007, the world used 260 million tons of plastics. So in New Zealand, we use around 300,000 tons of plastic every year. In European countries, they recycle about 50% of the plastic consumed. However, in New Zealand, we recycle about 24, roughly a quarter of the plastic we use. And even in the recycled plastic in New Zealand, we do not process all of them. We sell overseas for most of the recycled plastics because the limitation for processing in New Zealand. And so we have, in the end, we have about 252,000 tons of plastic in the landfills. It takes 100 years to decompose for the plastic in the landfills. So you can think of the problem potential. These data are from the website over here, Plastic New Zealand. Okay, so every KV consumes about 36 kilograms of plastic a year. And we recycle about 8.5 kilograms and dumped 27 kilograms every year. So that is a big issue. So we have some limitation for the processing, So we pack the plastic recycled, even in Christchurch, and we send to overseas for processing, not only to China and Indonesia, but also to European countries. Why we sell the plastic recycled to European countries? Because European countries got some subsidies for processing plastics. So we sell over a very long distance from New Zealand to Denmark to Portugal for the recycled plastics. That is one problem. And if we look at the plastics we are using, are you aware with these numbers? Yeah, so if you look at carefully about the plastic product, you can see some numbers, 1, 2, 3 to 7. And you got 1 is PETE, this is polyethylene, terephthalate, and this is high density polyethylene, vinyl, low density polyethylene, polypropylene, and others, polystyrene, and others. So that is, we have different type of plastics and we are using. And then this is the recycled plastic composition. You can see a lot of plastics we recycled are HDPE, low density polyethylene, and high density polyethylene, and PET. So that's it. We have this, a lot of plastics recycled, and we have not yet processed yet. So that's a potential to use this plastic for a value added and the product. And on this background, we have a research project, and we developed a new product and using the recycled plastic and wood sawdust to make a value-added product which can be used for building materials. And if the materials is stable and durable, does not need any chemical treatment, and then we can win-win situation. We can use the waste materials, and then we can produce a good product for building applications. Okay, so this product can solve 2 problems. And what is a wood plastic composite? That is the product's name. It's a wood plastic composite. The wood plastic composite is made of wood in the form of fibers or wood flour and plastics, normally with the coupling agent. So we have to add some coupling agent, a very small proportion, and to hold the both 2 materials together. The plastic is hydrophobic, is that right? Does not like water. And the wood is hydrophilic, it's like water. They don't like each other. So we have to add something for them to hold together, forced plastic and wood to hold together, and then we can make a good product. And the production line is, firstly, we got a mixing to mix the wood and the plastic, make it uniformly mix them together, is also called compounding. And then we use a mold, either injection molding or hot press molding, to make a solid product. So these are some products, if you like to see, and I'll got some samples. Okay. Oh. So what I have here, I got some recycled plastic. You got this food container, and then you got some sawdust inside, and then we got some sawdust. You can see here, and then we got some product. This is the product we made. So if we use the very waste materials, and then we put them together, make a product, you can feel whether how do you feel the materials is strong and stable. Okay, so the product is made of plastic and wood. However, not every type of plastic can be used for this product. So we have to select a certain type of plastic to make this product. And we know there are 2 types of the plastic. One is called thermosetting plastics. And this type of plastic is also called thermosets. These plastics can cure to a strong form and through heating. However, once this plastic is set and the material cannot be resolvent, you only use once for these thermal setting plastics, like phenolics and epoxy, polystyrene, and silicons, and this kind of product is the thermal setting plastics. And this type of product, because you cannot resolvent, and then cannot be used as for this product. However, we can use the thermoplastics. The thermoplastics are plastics which are deformable, melt to a liquid form when it's heated, and become hard and strong when it's cooled down to room temperature. However, you can recycle, you can reheat these type of materials and get a resolvent, and then you can get to use this plastic to form to make this composite, this wood plastic composite. Examples for thermoplastics are high-density polyethylene, polypropylene, polystyrene, and PET. So this kind of product and can be used for the wood plastic composite. If you look at the label of numbers, and most of the plastics product are thermoplastic. So hopefully we can use some of these recycled plastic for making wood plastic composite. Okay, so however, if we want to use this composite for building materials, and we need to know what's the required properties for building. So we need the materials to be stable. That means when you expose the materials to a changing humidity conditions, it's stable. You don't change too much. And if you put the materials in the water, you do not absorb too much water, and the material does not change too much in dimension. So that is stable and durable. If you use the materials, and for a long time, you don't want the material to lose the integrity. You don't want the material to lose the strength, the stiffness, and the properties. So that is durable. And appropriate mechanical properties are needed. So stiffness, that is also called Young's modulus or modulus of elasticity, and strength, and that is also people use the modulus of rupture. Okay, so give you more explanation about this stiffness and strength. But this is a very typical engineering term. If you are not an engineer, you may feel not very familiar with these terms. And this is the product. For give you some explanation about the stiffness and the strength of materials. So if you give a common explanation about the strength, is the material's maximum stress at a point when the materials fails, either by yield or by breakage. So if this is materials, and if under stress, and the initial length is L0, and after stretch is L, and the changes in terms of the length is delta L. So if you plot the load against the deformation, the length changes, and you can get this curve. So if the materials is stiffer, and this curve will be steeper. That means on the same load, the material change less. If you got that is higher and stiffness. So the stiffness is a capacity to resist deformation for the materials. If the material is stronger, and when the materials breaks, and the load is higher. So if you convert the load deformation curve into it's a more specific term, it's called stress. That is the load divided by the cross section, and then the strain is the length change divided by the original length. If you plot the stress and strain, that is this curve is not affected by the size of the materials, by the load and of the materials. So this curve reflects the property of the material. If you got a material very stiffer, and that means this slope is quite steep. This curve is very steep. If the material is strong, and the stress is quite high. So when we build a house, we like the material to be stiff, stiffer and stronger. Is that right? So that is the property and we need for building a structure. Okay, so what's the key features for the wood plastic composite? The materials is more stable compared to wood. If you put the materials in water, it does not change much, does not absorb much water, does not change much in terms of dimension. It's a lower processing temperature, so we can use comparing to steel and concrete, and then we use a normal 180 to 200 degrees C to process these materials. So it's much lower energy needed for processing these materials. And the lower weight to strength ratio, that means if you got this high strength, you don't need too much materials and compared to steel and concrete. And durable compared to wood, anti-insect attack, UV resistant, and anti-decay can be used to substitute the chemically treated wood. So that is a good thing. And can be recycled. The material, when you use once, and then you can recycle and reuse again. And can be easily decomposed. And you don't need to send to the landfill. You can easily bury it in the soil and then can decompose. Stronger and stiffer than pure plastic, and these materials is stronger and stiffer than pure plastics. So that is a good thing. And in the last 10 or 20 years, there are quite a number of development about the wood plastic composite. So in the US and the European countries, the wood plastic composite is already in the market. However, for the European countries, for the United States, they use a virgin plastic. If you look at the virgin plastic, you can see this is, you can see here, it's quite white, quite clear. This is a virgin plastic and made from petroleum and plant processing. However, almost all of the product are made of wood and virgin plastic in the market. So in the US and European countries, the wood virgin plastic composite have been used for decking, for the molding in the house, you got a molding, for the window frame, for wall paneling, for automobile parts, and also outdoor furniture and playground. So that is already in the application for the virgin plastic. Our project, we use recycled plastic. So what's the benefit for using recycled plastic? And the environmental benefit is obvious. Right? You can reduce the landfill and solid waste. And also the cost is lower. The recycled high-density polyethylene plastic are 31 to 34% cheaper than the virgin plastic. How about the properties? And surprisingly, the properties are quite similar between the virgin plastic and the recycled plastic, even is a little bit better. So we still try to study to understand why the recycled plastic has a little bit better strength, a little bit better and a modulus and of elasticity. So you can see slightly different, slightly better. And the processing in our product is through, normally you can do the processing through either press molding or through the injection molding. The current wood plastic composite at the moment in the market is mainly made through the injection molding. And we developed a technology using press molding. What happens is we firstly mix the wood particles and the plastic and mix them together through a compounding machine. And then we put in the hot press to form a sheet. If you already seen that, it's after the hot press that the product has been made. Of course, you can make a more complicated shape of product using the hot press. What's a good thing? What's the benefit for using hot press? The surface property is much good. It's much better. If you want to look at the injection molding, two samples from a company they use injection molding. You can feel the surface. If you feel the surface, you can see the surface is quite different. This surface is not as good as a hot press and product. So if you look at the flat sheet, hot pressed product, it's very smooth and also very durable, the surface with hot pressing and manufacturing. Okay, so what's new in our work? As I mentioned, we use recycled plastic. We use hot press molding process. We use optimized processing conditions to make the product which has most desirable properties. We test test the materials for stability, durability, strength, stiffness, and accelerated weathering conditions. And of course, we cannot leave the materials in a natural condition because otherwise we have to take many years. Even after my retirement, we have still going on for testing the material durability. So we have to use a way to accelerate the weathering condition to test the materials. I will tell you how we did that later on. And we compare the materials we made and the materials with virgin plastic. As I mentioned, in the market, the virgin plastic composite are already available in the market. So let's see what's the difference if we use a recycled plastic and to making the similar product. Okay, so what we use the material is radiata pine. It's a very popular softwood in New Zealand. We use the sawdust and dried and milled to a wood flour with particle size is 0.2 to 0.5 millimeters. And we use the thermoplastics. We use recycled high-density polyethylene and polypropylene. And also, at the same time, we use a virgin plastic for the comparison with the recycled plastic. Okay, so we add a small proportion of coupling agent, as I mentioned, to hold the two materials together. And we know the wood is hydrophilic and the plastic are hydrophobic. So we have to make them stay together. This is the equipment we have in the Department of Chemical Engineering. So this is we bought the extruder, and thanks for the college, give me a couple years ago, give me a capital to buy this machine. And this is the hot press, and it was in the building and now it disappeared, but we have another press in the mechanical engineering to make the product. Because this press was in the Simon building before earthquake, and now the building has been demolished. However, we have another good press in the mechanical engineering, and these are the product we made. So you have seen that. And we developed formulation. You can see here we use a different proportion of the plastics, different proportion of the wood, a different and a very small proportion of coupling agent. This is a little bit of secrecy, and what's the coupling agent to hold them together. However, if you want to build a plant, I can tell you the secrets and formula here. So we use a different, you can see, if we see a V here is a virgin plastic, if you use a R here is recycled, and different proportion of wood and plastic. And then we can see what's the result. And also we did the same for the PP, is polypropylene and material. Okay, so we do the test. As I mentioned, we need to look at the stability. We put the materials in the water for 2 hours and 24 hours to see how much water is absorbed by the materials, what the dimensional changes when we put the materials in the water. And then we do the test for the mechanical properties. We do the tensile test. We do the bending test to get the stiffness and the strength of the materials. Okay, and now, as I mentioned, we also did accelerated and weathering test. We use accelerated freezing and thaw cycles. We put the materials in the freezer, and for 12 full cycles. Every cycle we got to put in the water for a week, and then put in the freezer for 24 hours at minus 27 degrees C, and then we thaw the materials for another 24 hours, and we measured the properties after 12 cycles. So after quite a long time cycle, we measure the properties. And also we did the accelerated UV exposure test. We put the materials in a UV box. We have a UV light to expose the material to the UV light, and then put in the UV light for 2,000 hours. So we have 2,000 hours exposure. During these cycles, we spray water, and we control the temperature at 50 to 60 degrees C. And then we measure the properties at preset cycles after the 2,000 hours to look at the mechanical property change, to look at the stability, and for both and accelerated weathering test to see what the property change. And these are the results. This is put the sample in the water. You can see the result here for 2 hours and 24 hours. So this is 100% of plastic. No surprise, almost nothing. No water is absorbed. And this is 70% of plastic and 30% of wood. And this absorbs some water. And then this is a recycled plastic. This is recycled plastic. And this is 60% of plastic and 40% of wood. This is 50-50. This is 2 hours. This is 24 hours. So if you look at this one, this is 50-50. Got a lot of water absorbed by the materials after 24 hours. However, this is much lower than the wood. If you put a piece of wood in the water for 24 hours, the wood can absorb quite a lot of water, at least 30%. So that is a lot. But however, when we add a little bit of compounding agent, and the water absorption is reduced quite significantly. So that's no surprise. When you hold the material together very firmly and stop the water get penetration. So you can see this is a very small water absorption. And correspondingly, if you have less water absorbed and the swell, and the thickness swell is quite small. You can see almost 0.5%. As I mentioned, if you put the real wood in the water for 24 hours, at least you got a 3 to 5% increase in the thickness direction. So you can see this is much smaller swelling. It's much more stable. So from this result, we can see the materials is quite stable, right? Absorbed much less water, and also thickness swelling, the dimensional changes is much smaller than wood. And then we look at the mechanical properties to look at this is what that's called. This is the strength. You got the strength. And if you got a pure plastic, it's a little bit higher. However, when you add wood, the strength is decreased a little bit. But if you add a little bit of coupling agent, and the strength is increased quite significantly. So that is the megapascal of this strength. It's almost 25. And the stiffness, this is the stiffness. As I mentioned, we like the materials to stiffer. It's a pure plastic. The stiffness for pure plastic is much lower. No surprise. If you try to bend the pure plastic, it's relatively easier. Is that right? If you add wood, the material is getting stiffer and stiffer. If you add a little bit of coupling agent, and it's very stiff, the stiffness is very high for these the materials. So if you look at the result, these are the formulation. These are the formulation we want to develop. Right? That is give you the best result for stability. How about the durability? So we from the accelerated weathering test, after a long time cycling of freezing and thaw, and then we measure the properties. These are the water absorption. After the recycling, we put the materials in the water to see whether the stability is reduced or not. If we look at that materials with a little bit of coupling agent, the water absorption is very low. So it's still quite low. After quite a long time, 12 cycles, the materials still quite stable. This is a control. This is freezing thaw cycles. This is the UV cycles. So a little bit increase, but still quite stable. So that is and then look at the property, the thickness swelling, the thickness changes. If you look at this formulation, it's still quite low, and less than 2%. After quite a long time accelerated weathering and cycling, the properties still, the material still quite stable. So from this result, we can claim the materials made the wood plastic composite and is quite stable and also durable. And then we look at the difference between the virgin plastic and the recycled plastic. If you have a V here, that is a virgin plastic. If you have a R here, that is recycled. So if you have the same formulation, 50% of plastic, virgin, 50% of wood, and 50% of recycled plastic, and 50% of wood, you can see the water absorption for the recycled plastic actually is a little bit lower than this virgin plastic. And this one, the dimensional changes, again, is a little bit lower than the virgin plastic. So we can argue, we can claim, with the wood plastic composite we made using recycled plastic have the similar or even better properties than the wood virgin plastic composite. All right? We can claim that based on this result. So that is a result. And then we see, what's this? And then you can see what's the market. Okay, it's good, the product is good, but I didn't tell you something not really good. It's the color. So if you use the recycled plastic, the color is not as clear as white as this one. So you can see the product, you got a dark color. However, a company, it's a painting company, recently contacted me. They want me to do a project to see what the painting and the property. If we got a very dark color and whether we can put some paint on the surface and still get a good color on the surface. We are still going on, continue doing research on this product to make it and paintable. Okay, so that is the result coming from our research. And then if you want to build a plant, you may worry, concerned about the dollars. So how much we can sell if we make this product for the decking, for example. At the moment, New Zealand consumes about 13,000 cubic meter wood for decking. Are you surprised? However, 2/3 of that materials is imported. Unfortunately, we sell a lot of wood, but also we buy a lot of wood, hardwood, for decking. And the price, if we use a pine, the price every cubic meter is about 1,300. If we use the imported wood, 3,500. If we use the eco deck, that is similar as the current market price for the wood virgin plastic composite for decking is $6,800 a cubic meter. So that's quite a lot. And if we use only, we try to occupy 10% of the market, that is 2,000 cubic meter. If you want to build a plant to produce 2,000 cubic meter a year, using the median price, you still can make how much money? 7 million, is that right? Almost 7 million. And then you got another price if you use materials for molding. And the price for the molding is a little bit higher if you use the pine. And this is the finger joint, prime, painted. That is 5,000. And so that is 5,000 for cubic meter. If you use the pine clear, it's 6,000 for cubic meter. If you use MDF, it's 3,000 and a cubic meter. So that is the price. Current, you can buy this product from a placemaker from meter 10. That is the price. Of course, they try to keep confidential. We found a way to get this price and from the market. Okay, so that is the price. And the cost, if you want to build a plant, not 2,000, but 1,000 cubic meter, and this product per year, we have density about 1,200. And then the total equipment and the installation cost is about 1.5 to 2 million. We went to China, and a contractor went to China, went to US, went to European countries to look at different machine, different equipment, and add them together is about 1.5 to 2 million, and for all of the equipment installation. And the total storage and building cost about 32,000 per year. And the operational cost, including the labor, the materials, the energy, is $1 per kilogram of product. So that is the cost. If you want to build a plant at this capacity, and every year the revenue is about 3.5 million. We use a medium price. Okay, so that is, of course, if you want to look at different scenarios, more detailed data, we are still going and continuing this research for the price analysis to see what the return, what the benefit, what the investment. Okay, so from this discussion, from this work, we conclude the recycled plastic of HDPE, high-density polyethylene, and PP, the polypropylene, can be successfully used to produce stable and durable and wood plastic composite. So that is based on the result we have got. Adding a small proportion of coupling agent can significantly improve the property of stability and durability. And the quality, except for the color, we didn't show you color, but the color is not as good as virgin plastic. However, the quality of other properties of the wood plastic composite using recycled plastic were similar or better than that of wood virgin plastic composite. And the two types of plastic, HDPE and PP, showed a similar trend for stability and durability. These two types of plastic are quite similar. And HDPE, do you know what's product we are using for the HDPE? The milk bottles. Okay, so the milk bottles is made of HDPE. If you want to make this product, you just collect your milk bottles in the garage. Okay, so and the PP is the food container, like the ice cream container, is made of PP. So they got quite similar properties if we make this product. And the wood recycled plastic composite are still durable, suitable for decking and molding and bathroom, kitchen paneling. You know, you may have some problem with if you have some wood panel in the bathroom and the kitchen, and sometimes you got moisture absorption, and then you lost some integrity of the material. So these materials are very suitable for decking, for molding, for bathroom, kitchen, and the kitchen paneling and outdoor applications, where in this case, the high stability and high durability are required. And it's economically viable to build a plant to make this product and as a building materials. So we do more analysis for the cost, for the price. Okay, so this project was sponsored by the New Zealand Foundation for Research and Science and Technology. Now it's called Ministry of Science and Innovation, MSI. And we have some industry partners, for example, MasterCard. They provide recycled plastic free, and of course, not that so expensive, but they supplied the product with quite a uniform property. And the research team, including Dr. Mark Steiger from mechanical engineering, Jinge Li, and from chemical engineering, and also PhD student. We got research collaborators of research, Forest Research Institute, now it's called SUN, and Agri-Research, and also we got support from the department and also the college for the capital. And thank you for the for your attention. That's all.